Hi and welcome to aarna.ml GPU cloud management software demo. In today's demo, we are going to see how to build a hyperscaler grade GPU cloud using the CMS 5.1 version of our product in a completely automated manner. But before we go into the demo, let me also briefly tell you about our product, especially for those who are new. So aarna.ml GPU cloud management software, CMS in short, enables GPU as a service providers to build a hyperscaler grade clouds, empowering transition from their static GPUs to a fully dynamic multi-tenant and on-demand infrastructure. So what you see below is the GPU grid. This is the NVIDIA depiction that shows the GPU grid, which is comprising of the central cloud and the edge GPU deployments. And aarna.ml GPU CMS is able to manage both central and edge deployments. And our product mainly is comprising of these two functional blocks. The first block is what we call as infra manager, and this block helps to achieve a fully isolated multi-tenant environment for every tenant. And we term this multi-tenancy as a 7-layered multi-tenancy or 7 pillar multi-tenancy, and that is comprising of the CPU, GPU, the Spectrum-X Ethernet fabric, the InfiniBand fabric, the NVLink, the external storage, and finally the external gateway. So with this layer, for every tenant, we ensure that they have a secured and hard isolations across all of these 7 pillars. And once we have achieved this hard isolation, how to monetize is what this PaaS and self-service layer enables. Mechanisms that we allow for the monetization by the end consumers is through consumption of this infrastructure in various ways, which could be a bare metal as a service, which could be a VM as a service, which could be PaaS, platform as a service, and along with job submissions and model inferencing kinds of services. This is the typical demo configuration. So what we are going to show you in a demo is one scalable unit, which is comprising of multi-tier core, spine and leaf switches, which is comprising of multiple GPU nodes, the external storage servers, and the Aarna software itself sits in a management network. It is connected to the whole compute fabric through an in-band network, through a converged network, and we also connect to out-of-band network, all the day zero provisioning. So this is the typical production like scenario that we are showing you in the demo, and with this you achieve this east, west and north, south traffic isolation. Let me just also brief you on what the demo storyline is. There are multiple user personas, the NCP admin who is a super user, tenant admins, and the end users, which are the tenant users. So how we'll start with the demo is we'll first set up the infrastructure. So this is typically an NCP admin job, and we have automated this to an extent that the whole infrastructure discovery, underlay configurations, topology validation, setting up the catalog, billing and everything, this is all done in an automated way. There are no manual steps involved. So NCP admin, once he's able to do all of this, then we'll show you how tenant users are able to consume this infra. So they will create the VPC subnet and security group for themselves, and then they will consume the infra while by allocating the bare metal virtual machines, the Kubernetes cluster, and finally is the serverless inferencing. So let's log in as an NCP admin, and we'll start with the overall infra discovery flow. And in this infra discovery flow, what we are going to give is all the details of the high level MAC addresses of the core switches. We'll be giving the details of the gateway and the border leaf switches, etc. And then all the topology discovery takes place in a completely automated way using the LLDP protocol. So we are all giving the inputs that are required. We are now adding the details of the external gateway, border leaf and external IP details, so that we are able to link that to a topology, and that helps us while creating the external gateway multi-tenancy. And here we have integrated with F5 as an external gateway. So the tenants can also ask for the public IP addresses for a few of the bare metals that they wish to be reachable from the internet, and that is what we have specified. We have reviewing this, and then once we have reviewed, we start the infra discovery. And once the infra is discovered, this is how you view. It is a connected topology consisting of all core, spine, leaf switches. You see all the connection details between the switches and the other components. You see all the management, compute and storage nodes, all the switches. You can click to any of the node, and then you can see how those nodes are connected to each other. Then we move on to now onboarding the telemetry, which is NetQ, and this is used for the switch telemetry monitoring. Now, once we have discovered the topology, onboard the telemetry, we are now doing the topology validation, because what we have discovered needs to be in line with what has been designed. And if in case there is some discrepancy, the software is able to show that. But here it's all success, so we are doubly sure that the topology discovered is as per the design. And then we trigger the underlay configurations. As part of underlay configurations based on the NVIDIA reference architecture, all the IP assignments, the BGP settings and all everything take place. So now we have the discovered infra that is able to talk to each other. We are subscribing to few NetQ events so that we can monitor. And now we are setting the catalog pricing, because this is what will be available to the tenant user for actually subscribing. So NCP admin is setting up the price and he will save it. We have integrated with a billing module called Monetize 360, and this is all transparent to the end user. So here we are creating the tenant which will get added into the billing system. We are specifying the billing parameters like the currency, the frequency of billing, etc. That will all get configured in the billing system. And under the tenant, we are creating a tenant user. Now the user to whom we had asked for registration, he has received the email and is signing up using that email. So this is the sign up procedure for the end tenant. So he has signed up and he will start with creating the VPCs. So this is typically a tenant admin who is creating the VPCs, say for compute fabric. He is creating the subnet for that. We can create multiple VPCs and multiple subnet. So here in this example, we are also creating for a converged network, which will be useful for communicating with the external storage. So we have created two VPCs here and two subnets. We'll also specify the security group. So in this particular demo, we have integrated with F5 for creating all of these firewall related configurations for tenant. And then once these are all created, we are moving ahead with the bare metal allocation flow as a first step. So here we are selecting the bare metal, we are selecting the VPCs that we just created. And then you can see that the bare metals are being provisioned. You can see 3 servers, those are getting provisioned. Now we are moving to the external storage allocation, because you also need to have an external storage through which your training data can be accessed. So this is all in a seamless way. We just specify the size and you can see that that's all has been provisioned. So now you have the metal allocated, the storage allocated, you have the VPCs in place, and you are now seeing the compute node observability. You can see from a single pane of glass observability matrix. Now let's move on. We will start with the VM allocation now that you have seen the bare metal. So this is also a very simple step. You just go and say that we need a VM. You give the name to the instance, you select the flavor, you specify the SSH key so that you can access it, and then just say allocate. And so you can see that the VM provisioning is taking place with the options that you have selected. So this is really very simple way of allocating the VM. Now we'll start allocating a cluster, because we saw bare metal VM. Now there are also scenarios where we need to allocate a Kubernetes cluster. So the steps again here are very simple. Just go select the name, select the Kubernetes version, whether we want upstream Kubernetes or any of the other Kubernetes versions also that we support, like Red Hat, SUSE, etc. We have selected installing NVIDIA GPU tools, and then you can see the nodes, the bare metal nodes. You can select those nodes that needs to be part of the cluster, and we just say create cluster. Will say now it is running because it has been created. Now we'll go to the PaaS features or the model inferencing feature. So here we are going to deploy a DeepSeek model. We create an endpoint that will be accessible to the end user. We are giving the endpoint a name. Now we are selecting the model, which is a DeepSeek model from the Hugging Face, and then say deploy. The endpoint is created. As you can see here, this is a playground where the end user can type any of the prompt and he will get a response. Now we will log in and see the billing part, because now as an NCP admin we need to log in and just we can generate the invoice for that. You can see the invoice summary here. Download the invoice. So this is all what we had for today's demo. Thank you. Thank you for watching.